Hello and welcome. My name is Maciej Soja, and in this video I will talk about ground measurements of forests. Remote sensing uses indirect measurements to get better knowledge about our environment. The measured signal may contain information about the parameter that we want to estimate, for example forest biomass, but usually it will also have other contributions hindering the estimation of this parameter from the measured signal. For example, contribution of the atmosphere or of the measurement system itself. Development of models for the estimation of this valuable parameter from the measured signal usually requires some reference knowledge about the target. Therefore, ground measurements are a necessary part in remote sensing. They are typically used for model selection, calibration, and validation. The most straightforward method to obtain reference data on the forest is by means of destructive inventories. These inventories consist of harvesting the relevant trees and measuring their parameters. Typically, a tree is felled and chopped into smaller pieces, which are sorted according to size, function, etc. If we want to estimate above-ground dry biomass, the tree pieces are first dried, and thereafter they are weighed. This is definitely the most accurate method for biomass estimation on the ground. Naturally, this approach is not useful or feasible on a larger scale, but destructive inventories are still needed in studies of natural relationships between parameters such as size, mass, and volume. An actively researched topic is the implementation of an automatic measurement system on harvesters. Tree parameters such as stem diameter, stem profile, and wet biomass could then be measured whenever harvesting is made, which would significantly extend the database with available ground measured data. Data acquired during destructive inventories can be used to study the natural relationships between tree parameters. For example, apart from weighing the wood pieces obtained in a destructive inventory, the length of these wood pieces can also be measured. The measured quantities can thereafter be related to each other using functional expressions, the so-called allometric equations. Using allometric equations, parameters which typically are difficult to measure, like biomass or stem volume, can be estimated from parameters which are easier to measure, like stem diameter or tree height. Of course, the quantities estimated using allometric equations will be affected by errors due to natural variations and measurement inaccuracies. Moreover, they may also be subject to errors due to inaccuracies in the allometric model. However, these effects can be minimized with a well-designed methodology, and allometric equations are still a very useful tool. An important aspect to consider when working with allometric equations is that they are strictly data dependent. In other words, they can be very inaccurate if the data on which they are used are very different from the data from which they have once been derived. Non-destructive inventories typically rely on the use of allometric equations together with non-destructive field measurements. Many countries have established national forest inventories, which aim at regular assessment of the national forest resources. Although the exact methodology may differ greatly between the different inventories, due to different forest types, different goals of the inventories, different assets, etc., the general approach is typically common. The first step is to lay out plots within the test site. The plots may be laid out in a systematic grid, in a random manner, or in whichever way that is found most suitable. The plots are then visited by specialists who measure the parameters of trees within each plot. Commonly, small trees and trees with stems outside the plot are not sampled. Likewise, dead trees are typically omitted. For the trees chosen for sampling, a number of parameters are measured. The easiest parameters to measure are diameter at breast height, dBH, and species. Many automatic calipers also have a positioning system like GPS for easy determination of tree positions. Also, tree height can be measured relatively easily. The measurement of tree age is more tricky, as it requires taking a sample from the stem and counting the rings. Once the measurements are done, allometric formulas can be used to estimate parameters which have not been measured. Biomass and stem volume are typically estimated in this way. Thereafter, estimates can be aggregated to plot level and finally to stand level, entire test sites, or even countries. The main advantage of this approach is that it requires relatively simple measurements in the field. With a well-designed methodology, this is also an accurate method. However, good allometric formulas are required, and field inventories are still time-consuming and thus expensive. Terrestrial laser scanning is a technique in which a rotating laser sensor scans the surroundings and measures distance at high spatial and range resolutions. Modern systems can make more than 1 billion measurements per second, which gives an incredibly dense model of the surrounding forest. Terrestrial laser scanning systems, or TLS systems, measure range using either one of two different techniques. Some systems transmit continuous periodic signals and measure distance using the phase shift between the transmitted and received signal. Typically, several frequencies are used to extend the measurement range and avoid ambiguities. The advantage of phase shift systems is their better sampling frequency, but at the cost of shorter operational range. Other systems transmit pulses and measure distance using the time difference between the transmitted and received signals. These time-of-flight systems can measure at longer ranges, but at the cost of lower sampling frequency. One significant disadvantage of TLS is the problem of shadowing. A typical TLS campaign consists therefore of several measurements conducted from a few positions in the forest. This way, the same forest is illuminated from different directions. Once the scannings have been done, a three-dimensional point cloud model of the forest can be created. From this point cloud, forest parameters can be estimated by studying the shape and position of the separate trees. Currently, TLS systems are still expensive and large-scale use of TLS is time-consuming. However, as the technique becomes more popular, the costs are expected to decrease. Also, by mounting a TLS system on a moving platform, the problem of shadowing can be minimized. Who knows? Maybe in some years, wild animals will be equipped with miniature laser scanners with internet connection, and forest mapping will be taken to another level. Thank you, and see you soon again.